Hello dear students, welcome to Swayam channel number 15. Course title Pharmaceutical Organic Chemistry 1. Lecture title Classification, Nomenclature and Isomerism Part 2. In the last session we have seen Part 1. In this session we will see Part 2. Module number 1, so that is from unit number 1 and lecture number 2. This course it is as per Pharmacy Council of India New Delhi syllabus, and it will benefit first year students in second sem. So myself, course coordinator, Mr. Dhamak Vikrant Murlidhar, affiliated to Savitribai Phule Pune University. Name of academic expert Dr. Ramesh L. Sawant sir. Project name DTS Swayam sponsored by MHRD, New Delhi. Now let us see the learning objective of the session. So there are learning objective of the session, that is only one, it is for different classes. To study the IUPAC nomenclature of following classes. So these are the different classes. First one will be Alkanes, Cycloalkanes, Alkynes. We will see certain cycloalkanes examples also in this class. Alkynes, Alkyl Halides, after that alcohols, after that ether, after that Oxirane. So these are some classes that we will study in the session. Now let's see the content. Contents are similar as the learning objectives. So that is IUPAC nomenclature of following classes, that is alkanes, cycloalkanes, alkenes, after that alkynes, alkyl halides, after that alcohols, ethers, and oxirane. So these are the contents of the session, and we will see each and every class. Actually, generally there are similar kind of rules, but according to the classes, at the end rule it has been little bit different for each class. Means naming it is different for each class. To understand IUPAC nomenclature, first one should understand what is IUPAC. It is also said to be an IUPAC. It is International Union of Pure and Applied Chemistry. It is one of a union, and this union, it is world authority on chemical nomenclature and terminology. Worldwide it has been accepted, whatever the names they have been given by this IUPAC, they have been accepted worldwide. So this the authority, it works on chemical nomenclature, terminology, including naming of new elements in the periodic table, and also standardization method for measurement, and on atomic weights and many other critical evaluated data. So that is the work or the authority of this IUPAC. Now we will see the rules for IUPAC nomenclature. There are certain rules which are common, only the naming at the last it will be different for different classes, but the rules are similar. See the rule number 1, that is select the longest continuous carbon chain. We will see it with an example. Just understand the rule at the first instant. Rule number 2, name the longest chain. After that, number the longest chain. And fourth one, it is identify the substituent on the longest chain. And fifth one, put the prefix the position, number and name of the substituent on to the parent name. So name and number should be separated by an hyphen. There are different rules also. Different means there are further rules also. So that we will also see. But for this we will see one example and then we will move further. So I will write here an example. I will write an example here. So this is an example. See in this example, now what I have to do, I have to select the longest chain. If I select 1, 2, 3, 4, so this it becomes of only a 4 carbon. 1, 2, 3, and 4. Again, it becomes an only of an 4 carbon. Now, what I have to do, I have to select the longest chain. 1, 2, 3, 4, 5. So now it becomes a longest chain, right? So this it is an longest chain. Now, what I have to do first is that longest chain selection. Now I have done it, right? And second is that name the longest chain. So identify the number of carbons 1, 2, 3, 4, 5. So the name of our longest chain, it is an I will write here, it is pentane, as there are 4 carbon. It is an alkane chain, right? When the chain it will be different, the name it will be different over here also, means the suffix it will be different. Now what I have to do after that, number the longest chain. See the numbering of a longest chain. If I start from numbering this carbon 1, 2, 3, 4 and 5. So this numbering is correct, but the problem when there are this substituent, right, it is at the middle, so this numbering it will be correct. If I start numbering from here also, this numbering is also correct, because from both the sides of carbon it becomes at number 3, right? So carbon it is at number 3, so here it will be at the substituent. Next step is to identify the substituent. So identify the substituent. The substituent it is at number 3. So the substituent what it is? It is an methyl. So I will write here methyl, and prefix the number and name of the substituent. Right? At 3 number carbon, this methyl it has been substituted. So I will write here 3, and it should be separated by hyphen. Whenever there is a number, it should be separated by a hyphen. So now it's 3 hyphen methyl pentane, right? 3 methyl pentane. So this is the name of the compound. In this way, you have to write the name of compound. Now further, what are the rules further? So we will see. Identify the substituent by name and position and number, right? When 2 or more different substituents are present, their names are arranged in an alphabetical order. For an example here I will write the structure which is little bit different, so that you will understand this rule further. So I will write the substituents over here. See, now in this chain, the thing is that firstly what we have to do, we have to identify the longest chain. So certainly by looking towards this chain, so here if I modify it below, so there is one less carbon, so this it will be an longest chain. So it is of 1, 2, 3, 4, 5, 6, 7, 8. The chain it is of an octane. So I will write here name, that is octane, right? Octane. And now the thing is that I have to number this chain. If I start numbering from this side 1, 2, 3, 4, the substituent it is at 4th position, right? From this side, and if I start the numbering 1, 2, 3, 4. Now the problem with this, I will write from both the sides, then you will understand. See the 1, 2, 3, 4, 5, 6, 7, 8. And one more I will write with a different color. 1, 2, 3, 4, 5, 6, 7, 8. Now the question is that which numbering should be selected? Which numbering should be selected? See, in this case, don't consider this numbering. Why below numbering? The reason is that the substituent which is present at fourth position, it is ethyl substrate, right? And a carbon chain, it is big, and here it is only a methyl substrate. So we have to select the substrate which is having more number of carbons. So the upper numbering it is correct, below numbering it is wrong. So this numbering it is wrong. So don't consider this numbering. Only consider upper numbering, because though at from both the side it is at fourth position, though the position it is fourth or fifth fourth or fifth, but the here it contains an ethyl group substrate, and here it contains an methyl substrate. So we have to select the big substrate over here. So it is an ethyl substrate. Now what to do when two or different substrates are present? Their names are arranged in an alphabetical order. So ethyl E comes firstly, right, in alphabetical, and methyl it comes later. So I will write here the name of compound. So I will erase this and I will discuss about the name of compound. So it will be a numbering. So number, write a number, separate it with a hyphen, and it will be ethyl. After that, again separate with a hyphen. The number it is 5, right? 5, again separate with a hyphen, and after that methyl, and the name of the alkane chain, that is octane. So I have written as per the IUPAC nomenclature name of the compound. So these rules, whatever we have seen, in that also we have seen alkanes, alkane class. Now further class, that is cycloalkanes. So I will not discuss separately about an alkanes, because these are general rules which are similar for an naming of an alkanes. Now we'll see about an cycloalkanes. See, cycloalkanes are alkanes in which carbon atoms are arranged in a ring, and they are named by attaching the prefix cyclo to the name of an alkane having the same number of carbons as in the ring. For an example, we will see one by one. That is, cyclopropane is represented by a triangle. So I will write here a triangle. So this, it is a structure of cyclopropane. So it is equilateral triangle almost. And why it is been represented? These are showing three sides by a triangle. So now it becomes an cyclopropane. This is an actual representation of the triangle, what it is. After that, cyclobutane, it is represented by a square, because there are 4 carbons on the 4 lateral sides. So this CH2, CH2, after that CH2, here again it will be CH2, and here it becomes a square. So cyclobutane is represented by a square and a pentagon. Now cyclopentane, it is represented by a pentagon. So from above two structures, you might have understood that each corner it is having an CH2, right? When a cyclopentane kind of a structure, we will see that in the further examples, how that cyclopentane structure it has been written. And now further, cyclohexane. See the cyclohexane. This, it is a structure of an cyclohexane. So just put a cyclo in front of an alkene, it becomes an cycloalkanes, right? So cyclobutane, butane, as you know, it is having a 4 carbons and 8 hydrogens. So cyclobutane, right? Cyclopropane, as it has been shown. So just put a cyclo in the prefix, and you will get the compound. Now we'll see some examples from this class. Substituted cycloalkanes are named after alkyl cycloalkanes. So I will write here some examples. Here it is and cyclohexane. Here it is a structure of an cyclohexane, suppose, and it is having an alkyl substrate. So here I will write a methyl substrate. So how to name it? So for naming it, alkyl substance, whatever it is, and after that write cycloalkane. So cycloalkane, what it is? It is an cyclohexane. I will write the name of this compound. Firstly, cyclohexane, and here it is methyl. So I will write the methyl. Firstly, methyl cyclohexane is the name of compound. So whatever the substance it is having, you have to write it first. If instead of methyl it is chloro, then you have to write chlorocyclohexane. If it is there are two substances, you can write it di, tri, tetra, depending on your number it. Now the thing is that when the ring is designated as the substrate, if the alkane chain contains a greater number of carbon than the ring. So I will take here an example. So I will write an example over here. So this. So this, it is an butyl chain and it has been substituted on cyclopropane. Now the name of the compound, it will be not alkyl cycloalkanes. Means the name of the compound, it will be not butyl cyclopropane. This name, it is not correct. Why it is not correct? When the number of carbons they are greater than the ring, then we have to consider the ring as the substrate, right? So the correct name of this compound it is, so this, it is a wrong name. The correct name of this compound, it is cyclopropyl. As it is a methyl ring, alkyl ring, it will become ill at the last. Cyclopropyl butane. So this, it is a correct name for the compound, cyclopropyl butane. Though this cyclopropane ring, it is having a number of carbon less, so that is why I have taken the first chain which is of a big carbon, that is butane. So in this way we have to name when the compounds, it is when the chain it is bigger. When the chain it will be similar. If suppose here it is of an propyl chain and the structure it is of an cyclopropane, then in this we can utilize such kind of a nomenclature. Further class, that is alkenes. See, the general rules they are similar, just we will go to the final touch what modification it is having. It is having just modification in the name, but like selecting the longest chain, how to number it, and identify the substrate. So these all rules they are similar for all the classes. Alkenes are the hydrocarbon that contains carbon-carbon double bonds, and the name is obtained by dropping the final A and E from the name of corresponding alkane and adding E and E. Just A and E it has been dropped from alkanes and E and E it is added at the end. So we will see some examples, like this is one of a structure. So there are 3 carbons, and when there are 3 carbons it means that is an propane. But what we have to drop A and E in the propane, and we have to write E and E. So the structure it will become propene. Drop A and E and write E and E. So it will become propene. And so there is no need to number it, because the double bond can be at only first position in case of a propane. Either double bond it is from this side, so it will be similar, from this side it will be similar numbering. We will take one example from this class, that is now in this case how to number it. See, in this case we have to select the longest chain firstly. So this is only a longest chain. I will write the longest chain. So this is the longest chain, or you can modify this longest chain, so it will be similar because both they are having a branch of an CS3. Now what we have to do, we have to number it. So we will start numbering from the double bond. We will not start the numbering from a substituent that has been present. The priority it is higher for a double bond. We will come to that priority table in the next coming lectures. See, I will write here the numbering of this. So here numbering it will start 1, 2 and 3, 4. So don't start a numbering from this side. So if you start 1, 2, 3, 4, this will be a wrong numbering because double bond it is, see the location of double bond and start the numbering from that side. So double bond it is at carbon number 1 and the substituent it is at carbon number 3. So the name of this structure I will write over here. The name of the structure it is the name of the structure it will be so it is an butane. So I have to drop N and I have to write ENE at the last. So I will write here butane. And I have to write the location of double bond. So for that purpose I will write here 1 butane separated by hyphen, and I have to write one more, that is the substituent. So I have to write the substituent in front. So it is 3-methyl. It is 3-methyl 1-butane. 3-methyl 1-butane. Next class that is similar from an alkenes, but only the thing is that it is having a dienes. So di it means having it is having a 2 double bonds, so it becomes alkadines. So how to nomenclature that class? Alkenes containing double bonds are named as alkadines. So there are 2 double bonds. Now what I will do, I will write a structure over here. So this structure of an alkadine see this carbon, there are 3 carbons, and 3 carbon means it will become an propane. Now in case of an alkadine, similar as written over here, you have to write. So it will become propa. Instead of ANE, you have to replace it by in, but in case of an dienes, just replace, keep A as it is. So I will write here propa, right? Propa, and instead of ENE, I have written propa, and after that, I have to write dienes. So this ADI it has been now come in the middle when it is only a single double bond. When it comes only one time a double bond, then it is written as ENE. But ADI and after that ENE, propa dine, right? Now the further I will write one more structure. See this structure, now this structure it has 2 double bonds. If I locate the double bond from this carbon 1, 2, 3, 4, right, and if I locate from this 1, 2, 3, 4, both sides are similar, with both things are correct. When if there might be one more CS3 over here, then I have to start from this side only. So possibly find the lowest numbering for a double bond. So this is the lowest numbering, so there cannot be a lower numbering than this. And as I have to write now, here also I have missed one thing. I have not written the 1, 2 and 3. See here it will be 1, 2 propadiene, because location of double bond it is at carbon number 1 and 2. Here also I need to write it. Actually, if it is not written in case of an propadiene, it has been understood that at carbon number 1 and 2 there is double bond, because there cannot be a double bond at any other position. Now in this case, the double bonds, I have to mention the double bond, so it is at 1 and 3 number carbon. 1 and 3 number carbon, and it will become butadiene. So it becomes 1,3-butadiene. Now we'll see the third type in alkenes, so that is cycloalkanes. So how to name it? So we will see certain examples. Number the ring to give the double bonded carbon, and the double bonded carbon it should be number 1 and 2. Choose the direction that substituent get the lowest numbering, and position the double bond is not indicated, as it is known that it is in between 1 and 2. So I will write here an example. See this structure, it is of an cycloalkane, and if I put a double bond it becomes cycloalkene, right? So it is from a class of cycloalkene. Number the ring to give the double bonded carbon number 1 and 2. So this it will be carbon number 1 and 2, or you can write in the opposite way, as there is no substituent present over here. And after that, if the position of carbon double bond it is in between carbon number 1 and 2, as the double bond it is at here this carbon, so I have written it 1 and 2. So there is no need to indicate the double bond position if it is in between 1 and 2. Now the structure, the name of this structure, it will be cyclo. Instead of hexane I will write hexene, ENE. So ANE it has been replaced, and cyclo it is for in this cyclic ring. Now further what will happen? So here it is containing an I will write here a structure that is containing an pentagon, and this pentagon it is having, means it is an cyclopentane structure, and it is having a double bond, and here suppose say it is having a methyl substituent. Now what should be the name of this compound? So name of this compound I will write a numbering. So numbering it should be in this way only, 1, 2. I have to take this double bond between carbon number 1 and 2. If I start numbering from this side also, 1, 2, 3, 4, 5. So what I have to do? Possibly I have to find the lowest numbering of an substituent. So 1, 2 and 3 it is the lowest numbering of an substituent. If suppose say I will write that structure once again, and if I numbered it in different manner, so different manner means if I start numbering from here 1, 2, so this numbering it will be wrong. What nomenclature says that, or a rule says that you have to start the numbering from carbon 1 and 2, which is in between the double bond. So this it will be carbon number 1 and 2. So this cannot be in carbon number 1 directly, because we are identifying the substituent. So this numbering it is not correct. Whatever the numbering I have written earlier, it is right. So 1, 2 and 3. Now the structure it is of an I will write the name of the structure also. So it is 3-methyl cyclopentene. 3-methyl cyclopentene. So it is the structure of 3-methyl cyclopentene. So it has been crossed little bit, but it is pentene, ENE. 3-methyl cyclopentene. So there is no need to write location, because already it has been indicated that it is in between carbon number 1 and 2. Further class, that is IUPAC rules for naming alkynes. The name is obtained by dropping the final ANE from the name corresponding alkane and by adding at the end, that is YNE. So we will see certain examples from this class. See the name of, I will write here structures. See here the compound, that is the name of this compound I will write. There are 3 carbons and the name of this compound, it is propyne. Actually there is no need to locate the double bond because double bond it will be at always carbon number 1 in case of an propyne. So either from this side or from this side. Further molecules higher than propyne, so that has to be located by a double bond. So I will write some more structures over here. Here it is CH3. After that carbon triple bond C and CH3, right? So the name of this compound, it will be, firstly select the longest chain, so there is no branch, so that will be a longest chain. After that number it 1 2 3 4, there are no substituent present, and see the carbon, it is having the triple bond at carbon number 2. So here I should write 2, and see the longest chain, it is of an butane, so it will be butyne. The name of this compound, it will be butyne. I will write one more structure from this class, then you will understand it a little bit better. C triple bond C, CH2, after that CH, after that CH3, and here it will be CH3. Now I have to name this compound. So how to name the compound? See here, firstly I have to number it. For numbering I have to select the longest chain. So this can be a longest chain. So this can be a longest chain, or either you can modify. Both are similar, that it is having a CH3 at both the branch end. And here now I will number it. So I cannot number it from this side, right? Why? Because the triple bond has the highest priority than methyl group. Methyl group, it is having the lowest priority. So here I will number it from this carbon 1 2 3, right, 4 5 6. So there are 6 carbons in the longest chain, and methyl substituent it is at 5th position, and after that it is having a triple bond at carbon number 2. So I need to write the name of this compound. I will write the name. Firstly write the name of substituent at prefix. So it will be 5-methyl, as it is methyl substituent, separated by hyphen. Again write 2. Why 2? Because the triple bond it is at carbon number 2, and after that HEX YNE. YNE, it means it is an having a triple bond, right? So that is YNE, and there are 6 carbons, so that is hexene. Hexine. We will take one more example from this class, so that is quite similar with this dienes. See here I have to number this compound. So numbering, it will start from this carbon 1 2 3 4, or either you can write from this carbon 1 2 3 4. There is the longest chain, there is no branch, and there is no substituent. So only it is having a triple bond from both the ends. Triple bond, it is at same position, carbon number 1 and 3, carbon number 1 and 3. Only what I have to write, it is an alkadines, not that ENE. YNE. I will write the name of the compound now. See the triple bond location, it is at 1 and 3 position. So 1, 3, right? And here it will be buta, because it contains 4 carbons. Buta, DIYNE. Right? So there are 4 carbons and 1, 3 butadiene. Pronunciation, it is a little bit similar, but don't confuse, write the name correctly. Now we will see further class, that is alkyl halides. Alkyl halides are the compounds which contains carbon halogen bonds. Prefix the name of alkane by chloro, bromo, iodo and fluoro. So these are only the 4 halogens that we will come across, and so we have to write the prefix in this way. And as the rule states that in the alphabetic order we have to arrange the prefixes. So we will take an example from this class. So I will write very simple example, then we will go for a little bit complex example further. Say this, it is an, suppose so here it is alkyl halide, right? Alkyl halide. We will see further also, if it is in complex, how to write that complex structures also. It is very simple. In common names, this structure it is called ethyl bromide. Common name, it is an ethyl bromide. But when the structure it is it is named as per IUPAC, so we have to write bromoethane. Bromoethane, it is correct structure as per the IUPAC, bromoethane. We have to join this prefixes before an alkane. So whatever the halogens it is having, that we have to join further. Now we will take some more examples from this class. So this, it is suppose Br, it is containing an Br. Further it will be 2-bromo. Why 2-bromo? I will explain it. 2-bromo propane. See why 2-bromo propane? Because we have to select firstly a longest chain. So that is the longest chain, this one it will be. And after that 1, 2 and 3. So these are the 3 carbons. And I can number from any side because the substituent it is at middle only. If I number from this side 1, 2, 3, so it will be at middle only. So at number 2 it is having a halogen, that is 2-bromo. As we have to add a prefix, so 2-bromo, and after that carbon chain, so that is a propane. So don't make it any change between this this alkyl chain. So let it be as per an alkane only. Some more examples we will see in this class. So here it is CH3, CH2, CH, CH2Cl, and here it will be CH3. So the name of this compound, now firstly the thing is that select the longest chain. So this will be the longest chain that I have selected. So write this in this direction, and after that I need to identify the substituent. So there are 2 substituents and number it. So I cannot start numbering from this side because I have to possibly find the lowest substituent numbering. So numbering it will start from here 1, 2, 3, 4, right? 4, 1, 2, 3, 4. And after that what I need to do, I have to write the prefix in alphabetical order. So first it becomes chloro, and after that it will become methyl, because C comes first then M. So it will become 1, right? So 1, why? Because it is at number 1 carbon attached to a number 1 carbon. one chloro separated by hyphen, again that chloro, after that 2 again separated by hyphen, again separated by hyphen, after that methyl, and the name of a compound, that is butane. It is having 4 carbon, so that is why butane, and at number 2 it is having a methyl substrate. So 1 chloro 2 methyl butane, it is the name of a compound. Now next class, that is alcohols. Alcohols are named as alkanols. Instead of E in case of an alkanes, it has been replaced by OL. So the alkane, it contains A instead of this, and it has been now replaced by OL. Alcohols, it is called alkanols. We will see some examples from this class. Say suppose this very famous example which you will utilize a lot many times. As per the general name or general system, it is called ethyl alcohol, but as per the IUPAC name, it will be said as ethanol. See, A-N-E, only E it has been replaced by O-L, so it becomes ethanol. We will see one more example from this class. I will write here a structure. See, now this structure, it contains substituents, right? There are 2 substituents. So firstly I have to select the longest chain. So how to select the longest chain? So this will be a longest chain, or either you can modify here also. So both are similar methyl groups. Now number it. So numbering, we cannot start from this methyl substituent. We have to always see where is the location of an alcohol or OH group. So here I will start a numbering 1, 2, 3. If I start a numbering from this carbon 1, 2, 3, 4, it will be wrong. So starting from this carbon 1, 2, 3, and last one, that is 4. Now I need to write the name of the compound. See, this compound, it can be written. So the methyl, it is a substituent, so I will write here 3-methyl separated by hyphen. After that 1, I can write here 1 because OH group, it is at carbon number 1, 1 butanol, right? 3-methyl 1 butanol, and OL, it is referring that OH group, it is at number 1 carbon. We will see further examples from alkane diols. Just as similar what it has been written, in same way the diols, they are been written. Just put a name of an alkane in front and you can write the diols. Alcohols containing 2 or 3 OH groups are named as alkane diols or alkane triols. So whatever the 2, if there is 2, then write diols. If there are 3, then write triols. An important point to note over here is that when we are writing alkane diols or alkane triols, E it has been written. See, in case of an alcohol, OL, it becomes OL, but when we are writing diols or triols, E it is written as it is. Right? Just add in the suffix diols or triols. So whatever the compound it will be. I will take here an example. Right? Structure OH, CH, 2, CH2 and OH. See the name of this compound, it is an propane. This is the longest chain, and The longest chain, it has to be numbered. So 1, 2, 3, right? Propane. So 1, 3 propane, and there are two OH groups, so it will become diol. The name of this compound, it will be 1, 3 separated by hyphen propane, right? Alkane fully and then diol. We will take one more example from this class, that is often triols. Similar, very similar, only OH it is having in middle. Here it is having CH2OH, right? The name of this compound, I can start numbering from here also, 1, 2, 3, or I can start numbering from this below carbon also. It is similar because the groups, they are similar or attached to similar carbon, that is OH. So I will write here the name, that is 1, 2, 3, and the carbon chain, it is of an propane separated by hyphen propane, and write just triol because there are three OH groups, so triol. Now we'll see further class, that is ethers. They are called alkoxyalkanes. Alkane, it is written firstly, after that again oxy and again alkane, because it is having an oxygen in between. The smaller alkyl group plus the oxygen atom is called alkoxy substrate, and remaining part that will remain as it is, that is alkane. So for an example, I will write here an example. So in this compound or in this molecule, you can start numbering from here 1, 2, 3. As there is no substrate, so don't worry about the numbering. And at carbon number 1 or near to an oxygen, so 1, so it will be 1 methoxy propane. Why 1 methoxy? At carbon number 1, this oxygen and CH3 it is present, so 1 methoxy, and remaining part, that is propane. I will write one more example from this class. See, in this case, what I need to write, though this having a methyl substrate at carbon number 2, not carbon number 2 exactly, but I cannot start the numbering from here. See, this, it is the longest chain, right? So this, it will be a longest chain, and after that I have to write numbering. So I need to start from here because ether, it is having a higher priority compared to an methyl. So I cannot start from here. So this will be wrong. So 1, 2, 3, 4, here it will 5 and 6. And at carbon number 2, it is having ethoxy functional group. Because why ethoxy? Because it is an ethyl and oxygen, so it becomes ethoxy. So I will write the name of this compound. So it is 2-ethoxy. After that 5-methyl 2-ethoxy 5-methyl, it is hexane. 2-ethoxy 5-methyl, because at carbon number 5 it is having a methyl group, so it will be 5-methyl, and it is a chain of 6 carbon, so it is hexane. So this is the name of a compound, that is 2-ethoxy 5-methyl hexane. Now further, it is oxirane. Oxiranes are epoxides, are cyclic ethers in which ether oxygen is a part of a 3-membered ring. In IUPAC system, they are named as alkyl oxiranes. See how alkyl oxiranes, we will see now with an example. So instead of carbon over here, it is having an heteroatom, that is oxygen, and it becomes an oxirane. In the last session, we have studied this example in case of a classification of an organic compound, that was oxirane in heterocyclic ring, and it is an alicyclic kind of an hetero ring which is containing an oxygen. The general name of this compound, general name I am talking about, but in case of an IUPAC it is called oxirane, and in case of a general name it is called ethylene oxide, right? It is called ethylene oxide. Now what to do further if it is having an substituent on this CH2 or CH2. See, I will write such kind of an example further. Here it is showing a methyl substituent on the carbon, so it is 2-methyl oxirane, 2-methyl oxirane, and here propylene oxide. The name of general name, it is propylene oxide, so don't concentrate on the general name. See here I have written 2-methyl oxirane. Why? Because carbon number, not carbon number, we have to number it from this oxygen 1 2, so it becomes 2, right? And further, if it is having a substituent at both the positions, so then what to write, right? So I will draw here one more structure. I will not write this CH now at the corner end. Here it is CH3. So now in this case, what to do? 1 2 and 1 2, both are similar, so write but what we need to do, we need to rearrange it properly. So 1 2 3, right? So it will become 1 2 3, and if I start from this carbon also, it will become 1 2 3. So depending on what kind of a substituent it is having, so here the substituent both are similar, right? So in this case I have to write 2 3, right? Dimethyl, because a substituent of there of a methyl, so it will become 2-3 dimethyl oxirane. And one more structure I will write over here now with a different. So here it is oxygen, I missed oxygen, 1 2, right? The carbon number 2, it is having 2 substituent, that is 2 dimethyl oxirane. Oxirane. And the common name for this compound it is isobutylene oxide. So carbon number 2 it contains 2 methyl groups, so I have written 2,2-dimethyl oxirane. Now let us see the summary of the session. So these are general rules what we have seen. Firstly, select the longest chain of an carbon. After that, name the longest chain. After that, rule 3 it was number the longest chain. And rule 4 that identify the substrate. Rule 5 prefix the position number and name of the substrate onto the parent name. And the name and number should be separated by hyphen. After that, we have seen rule number 6, identify the substrate by name and position numbers. And we need to arrange in alphabetical order when there are 2 or more substrates present. And there are some priorities that we have seen. If it is a methyl group, it will have a lowest priority. But when it is alcohol or when it is any other double bond, triple bond, it will have the highest priority. So according to that, we have to number it. So we have seen alkanes, naming of an alkanes by this IUPAC nomenclature. After that, alkenes are formed by dropping A and E in alkenes with A and E. So just drop A and E and write E and E instead of that. When it is having a double bond, when it is having a triple bond, in case of an alkanes, drop A and E and write Y and E. So it will become alkyne. After that, we have seen alkyl halides. So alkyl halides are named by adding prefix of halo. So halo, that may be chloro, fluoro, iodo or bromo, and then write alkane, whatever it will be. Like we have seen chloro, ethane, such kind of compounds. After that, alcohols are formed by dropping E. In case of an alkane, just drop this E and it by an OL, right? OL instead of this E, so it will become alkanol. We have seen ethanol kind of structures in this class. After that, ethers are named as alkoxyalkane. See this alkoxyalkane, it is the smallest part. The smallest part of an alkyl, it is written with oxy. So like example, ethoxy, methoxy, propoxy. So this and the bigger part of an alkane, it is written as it is. So we have seen one of an example, that is 1-methoxypropane from this class, and other examples also from this class. After that, oxiranes are cyclic ethers with 3-membered ring. In between it is having an oxygen atom, and there are 2 CH2 at the both end which are connected totally in the ring. And if it is having the substance, such kind of examples also we have seen from these classes. So thank you. With this, we have completed classification, nomenclature and isomerism part 2 from module number 1, and this was lecture number 2. So thank you for attending it.